Hi, my name is Jennifer Sills Almeida. Today I will be going over Anova test, actually an SPSS. I'm going to start with the research question. The research question today is this: Is there a significant difference in reading scores among students with low, medium, and high socioeconomic status at Lamar Middle School? So, what we're doing is we're seeing is there a difference among students? So, if they're ranked for the socioeconomic status low, medium, high, is there a difference between those scores, those reading scores? Step 0 is question construction. So what we're going to look at before starting SPSS is we are trying to ensure that our research question aligns with the statistical test to be run. So we know that the first thing is difference among socioeconomic status. So that is the primary verb. So we are looking at that and seeing what the primary verb would be in regards to that. And in this situation and stuff, it would be, is there a significant difference among? So among would be the primary verb. So the verb type would be comparative. So we're comparing this different socioeconomic status in an Anova test. The independent variable obviously will be the SES status, meaning low, medium, high. That's the independent value. And it is categorical. So we're putting it in categories, and the dependent value would be what is the effect on the reading scores based on the students and those different socioeconomic status categories. Now we are looking at a comparative verb, and also we have 3 independent groups: the low, medium, high. And we will be doing a one-way ANOVA. Now, the next one will be step 1, hypothesis. So we're looking at this. So when we are looking at this, we have to determine for the null hypothesis. Null hypothesis, we're asking over here, the null hypothesis stating there's no significant difference in reading scores among students with low, medium, and high socioeconomic status at Lamar Middle School, meaning it's mu sub 1 equals mu sub 2 equals mu sub 3, saying there's no significant difference in the reading scores based on those socioeconomic status. So the symbols shows there are seen and stuff. Mu 1 equals mu 2 equals mu 3. So the new null hypothesis is that there's no difference in reading scores, right, at all among these 3 groups. Now, the alternative hypothesis is that there is a significant difference in the reading scores. Now, when we're looking at this, I'll go into setting the alpha, but anything above 0.05 has a different effect and stuff on it. So if it's higher, there's no significance, but if it's lower than 0.05, our alpha, then there will be a difference. So let's jump there. And again, for the research, at least one. So if at least one mu is different between the groups and stuff, then that is why we're showing that there's a significant difference in the alternative hypothesis. So step 2, we're setting the alpha. So the alpha level is set at 0.05, and it is always non-directional. We never predict which group will score highest or lowest. And the F distribution does not have 2 tails. It starts at 0. So what this means is that it's always going to be a positive number, and it will have a right skew, meaning it's skewing to the right. The larger your F, the further into the rejection region you fall, further away from the null hypothesis. And ANOVA, it's good to know that has 2 degrees of freedom between the groups. So when we're looking at ANOVA and stuff, we're looking at the scores. We're looking at the mean scores of all low, medium, socioeconomic. Now, there could be a difference in the reading scores within the groups. That means the low groups, how many people are within that group and stuff, what is the difference there? And also between the groups, saying between low, medium, and high. So there's a within group and also between the groups. So we'll have to reject the null if P is, so we'll have to reject the null if P is less than 0.05. In our situation, it will be, but I'll show you in a second because it's at 0.01 for normality. We'll test that in a second. You retain the null, that means that there's no significant difference in that. So if it is, you retain the null if P is greater than 0.05. So let's go to part 3. So part 3, what this involves looking at, there's different assumptions that we have to make sure that we look at. Number 1, the first is design level assumptions. So whenever you're doing research, you have to look at how your design is. Now for this one, we know that the math scores, we have a scaled continuous dependent variable. So that's 1. Is it met? Yes, we do have dependent variables. Number 2 is 3 independent groups. Do we have 3 independent groups where the students are not in the same group, are not in 2 of the same? So if a student is placed in the low socioeconomic status, they can't also be in the medium or the high. This is what this means. Okay, the next level we're looking at assumptions is the data level assumptions. And the data level assumptions, what this consists of is we need to check for normality. So we need to see, is the bell curve normal and stuff? Is it normal within that? Like there's no significant difference? Or is there? Okay, so we're fixing to run it and stuff, and I'll show you that there is significant difference based on the 0.01. So I want to show you how we do that. So what you'll do is, so that we're going to go to SPSS. We have SPS here. We're going to go to Analyze, Descriptive Statistics, and then what you'll have to do is Explore. So I have put in some numbers, so let me just reset that for you. Oops, one moment. Well, we'll just leave. So for this one and stuff, when we're looking at it, let me explain it really quick. The dependent variable is what we're looking at. We're looking at the reading scores. How does the independent variables, which would be the factor list, affect the reading scores? So over here, so we would have to click reading score. And then we have that. That's going to be the dependent list and stuff. So it depends on what the independent, which is the social economic status of the students, is. So we'll put that in there. Now we'll check with the plots. We are going to run the histogram, factors level together. We want normality plots with tests. So we need to see, is this normal? Does it have a normal bell curve? And if not and stuff, then we need to find that out. So we hit continue and hit OK. Okay, so what we're doing here is now that we have this information, let's go over it. Let's look at it now. Okay, so social economic status. We see that the reading scores, what the reading scores are for each of the status. So low, medium, high. This is the number of students. So we have about 3,400 students. So out of the low social economic status, we have 1,079 students that fall under it. And the medium social economic status, we have 1,486 students that fall under it. And then under the high, we have 1,046 students that fall under it. So that is that descriptives. Now let's go into talking about the mean. So the reading scores of the low, because we're trying to see the difference based on the socioeconomic status, how does that affect the reading scores? Well, the low mean, it was at 89.18. So we know that the people that were in the low socioeconomic status, their reading score is at 89, so almost a 90, right? Now, for the medium and low, I think it's important to note that the medium ones had a score of 92.4, where the high socioeconomic status individuals had it at 92.46. So if you look at this, 92.4 for medium and 92.46 for high, it's only 0.06 difference. However, the score between the low and the medium and then low and the high is greater, right? 89 versus 92 for the medium. For the low and medium, and then between the low and high, it's 89.92.46. So we tested normality. We're looking at Shapiro-Wilk. So we have to determine, is this a normal bell curve? Is this normal? Now, what we need to remember is we set the alpha. So in educational research, usually it's set at 0.05. Well, if it's less than 0.05, it's significant. That means it's not normal. Okay, so I wanted to do that and explain it. So we know it's not normal. Let's go back, jump back into the slides I would like to explain really quick. So we ran the analysis, and what we have and stuff, like I went ahead and explained, the test normality and stuff. What we have is that the p value is 0.001, so statistically significant. It's way lower than the p set at 0.05, right? Because 0.001 is lower than 0.05. So what that means is that the data shows that it's not normally distributed. So we have to reject the null hypothesis that there wasn't a difference. So that is what that means. Now, next, we're going to go into the Levine's test, and I'll be explaining that in the next video, but I did want to let you know that we will be talking about that. And here you'll see the significance, 0.227 for the Levine's test, and how it was 0.05. So my next video will be up shortly. I hope you enjoyed the video, and I appreciate you listening.